In this video, we're going to do the problem. A container has a layer of benzene that is 5 centimeters thick and has a layer of mysterious fluid 7 centimeters thick that floats on top. A pressure gauge is inserted at the bottom of the container and reads 910 pascals. What is the density of the mysterious fluid? Alright, so since we have several layers of fluid and we're given the pressure at the bottom, that tells us that we're doing a pressure with depth problem. So I've drawn a diagram here on the side where I've drawn the layer of benzene and labeled how thick it is, the fluid and how thick it is. But the atmosphere, because we put a pressure gauge, which is going to give you gauge pressure at the bottom, we're not going to include the atmosphere. So we're just going to worry about the pressure from the two layers of fluid. Alright, so we're given the gauge pressure here, that's 910 pascals. Our first row GH is going to be for the benzene. So I'm going to look up the density of benzene and make sure it's in kilograms per meter cubed. If it's in grams per centimeter cubed, you can simply multiply by 1,000. Then times 9.8 times the height of just the benzene, so the 5 centimeters converted into meters is 0.05 meters. And then my second row GH term is going to be the density of the fluid that we're trying to solve for, times 9.8 times just the height of the mysterious fluid, so the 0.07 meters. I'm then going to do my algebra and isolate the density of the unknown fluid, and we find that it's 700 kilograms per meter cubed.